This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known. Well, thank you for being here in the Math Map Book Club, where every week Dr. Kirsty Gilpin and myself discuss another lesson from the Math Map being used by classical conversations communities across the globe. And we're just so appreciative of the parents jumping in now at the beginning of the school year and sending information and questions to the forum, as well as attending the book clubs. It's just really exciting to see more and more folks digging into math the way we do here at the book club. So Kirsty, thank you so much for leading us all these years.
Well, I appreciate you supporting us doing this, Lee, because I just think it's remarkable that you make yourself available to everybody every week to work through these ideas and answer questions. So thank you. We are on lesson 7, exponentiation, this week, which I always think is exciting because I just think I've learned a lot as we've worked on this lesson. And so it always excites me every year that we come to this. So as we start each week, we encourage you to spend time each day working with flashcards. And we've been talking about various strategies for using those flashcards, such as reading them together, making sure that you keep some of those cards that have been mastered in your pile so that you can celebrate and not always feel like you don't know something. Mixing your decks up, using them for review, combining them with games, playing fast facts, using them for copy work. And today's idea for using flashcards is to practice backwards. And so typically we look at our flashcards. I'm just going to pull one out. And we look at our flashcards, we show students this side and read the back side. But perhaps to go backwards, if you really want to stretch your child, is
Kirsty, could you hold it up a little higher so we can't see?
Yes.
It doesn't have to even be closer. We just couldn't see the whole card.
Sorry.
Okay, go ahead.
So instead of having them look at the top and you check with the answer on the back, look at the bottom and see if they can come up with what is the image on the other side. And they could do that by writing it as well as speaking it. So it may be a little bit slower. It may not be a fast fact kind of a way to go through your flashcards. But if they see what does a division equation look like, you could say, okay, well, write that out for me. What are some different ways we could write that out if we know that A is the dividend, B is the divisor, and C is the quotient? So it might not look exactly, right? We see it on the back written as a fraction. They might write it using another notation, but that's a way that you can use the flashcards, especially if it feels as though your students are getting close to mastering them, working backwards. It makes me think of how our National Memory Master students work through the timeline cards, and they have to go backwards and forwards and upside down, all those different ways that they work through the timeline, pulling some of those ideas in to work through these flashcards as well. We have had a question about math facts, and I'm going to answer that at the end of our call today, which is a little bit related to flashcards because they really are an efficient way for memorizing those facts. So if you are the mom that sent that question in, that answer is coming. Does anybody have anything they'd like to share about flashcards or something that's worked for you? Okay.
Whoops. Oh, sorry. I was talking. Could you hear me?
No, but we can now.
Okay. I was just going to say, I think I've shared this before in a book club, but one thing we do with flashcards that has worked really well for us is to have a little box with ones like a little dividers in it with the daily that will go over every day for until he gets them down pretty well. And then we move them to alternating odd or even days. And then we and then we move it to every day of the week, and then it goes back into the monthly section. So once a month, once he's completely got a fact down, it'll still be reviewed once a month. Now, I don't do those with all of the, the math fact card. It's more the notation cards we've used that with. But it's been a good way to really solidify ones that we maybe struggle more with. Does that make sense?
Thanks for sharing that again, Janet, because I remember you sharing that and thinking it was a great idea. So I'm going to steal it and add it to the slide so
Absolutely.
that we can share that. Thank you. All right. So also on day one, which may be everybody's favorite day of the week, because we start by talking about our cover. And if you hadn't heard before, Lee really wanted to provide a gentle introduction, a hospitable invitation into the math conversation. So we know that some of our families, because of the way we've been trained to see math, we have a tendency to skip over the cover and jump right to the lesson. And oftentimes we've been trained to just skip over all those words and go right to the exercises. And so if you're using the math map for the first time, there's some untraining that you have to do, because really with our emphasis, we don't want you to go straight to the computations. We want you to save those for last and recognize how much there is to learn before you ever look at those exercises. And that starts by looking intently at the cover. And it's a perfect opportunity to practice our core habits, our common topics, and our canons of rhetoric. And so this week we're looking at our core habits, which we use names to help us remember. And so our N stands for name. Can your students name the cover elements? So I'm going to click on my highlighter here. So I'm going to name them. It doesn't have to be in order, but I want you to see how intentional Lee was in designing the cover and helping our students to recognize that these elements are on the cover every week. So we have our dimension. We have our dimension symbol up in our top left. We have our domain name, monomials. We have the number set that our domain name fits under. We have a compass in the top right corner that has our lesson number in it. And then we have our lesson title. We have the piece of art that is consistent from domain to domain, along with the information about the artist. We have a quotation on the left, and we have a reflection on the right. And down in the bottom right-hand corner, we have the Math Map logo. So there's a lot of elements that are on every single cover, and they're there intentionally. And so just naming those with your student, helping them to attend to the cover and name those elements, is going to help them to see the continuity from booklet to booklet, as well as from year to year, domain to domain. We could attend to the number set of the domain. So as I pointed out, right, that's over here on our left-hand side in our border, which is really another element I didn't mention. I took that for granted, but notice the color of the border matches our domain. And so monomials, we're going to be focusing on using algebraic numbers. And fractions over here, there's our name. We're using rational numbers. And then integers, we have our integers. And so that Z, that Q, and that A is telling us the number set of the domain that we're in. We can memorize the symbols that represent the dimension. That's one thing to memorize, and we're going to practice it week after week, and then we'll get a new set, right? So in the top right corner, we could work on memorizing that 1D goes with a line. When we get to 2D, we could memorize that 2D goes with the grid, and so forth. We could look at the topic and ask our students if there's a way they could act out or express exponentiation. right? So I don't know why, but for me, when I think about exponentiation, it usually, right, if we have our base is more than 1, it gets big really quickly. Right? If we look at the curve, it's when we think about exponentiation, we usually are thinking about things that get big. And the idea that comes to mind is popcorn, right? Because it sits there and it kind of all of a sudden it's big, it pops, right? And so for me, right, maybe when I think of exponentiation, I could have my kids popping like popcorn. You could even count with them, working through, say, the powers of 2, right? So I have 1, then I have 2, and then I have 4, and then I have 8, and maybe when I get to 16, they pop. So that's a way that we could express the topic. And then asking our students to tell us a story about the art. And you could bring in elements of storytelling, like who are the characters? What's the setting? It doesn't have to necessarily be a math conversation about the art. You certainly could, in this case, talk about how many bunnies there are. We could talk about how many girls there are. We could compare what she's feeding them to, right? Does she have enough to feed them? So we could use mathematical ideas, but even just helping our students to practice those elements of story is going to be a worthwhile way of engaging them in this conversation and inviting them into the lesson for the week. I always think this is one of Lee's favorite pieces of art, and I may be wrong, but for years she would always talk about the bunnies. So I always think of Lee when I see this lesson.
Yeah, I is one of my favorite. I appreciate you talking about telling the story and expressing the way you did today, Kirsty, because remember, the world has told us the education is fragmented, and we cannot say enough times, no, it's integrated. So your math lessons should be crossing into other ideas about how just life is and the world exists and how we describe it.
Anybody have any other questions or testimonies to share about the cover?
I have a story about not this week's, but week 5 with multiplication. My daughter we look at the cover art together. My daughter is in challenge 1 doing the monomials, and my son is 3rd grade doing fractions. And we usually look at the cover art together, but my daughter was busy doing something else. So I was looking at it with my son, and we were talking about powers and how like 5 loaves to the Jesus power equals 5,000 plus people fed. And I thought that was really cute. And so we went on to like talk more about stuff to the Jesus power. And I just thought that was really cute the way that he expressed that.
Well done, Mom.
I also have a testimony to share. Like this last week, we were doing booklet 4, which adding and subtracting. And so Lee talked about being integrated. I'm the mom who everywhere I go, if we go hiking, we'll say, what are 3 types of rocks? And I'll try to put everything in together, and then people would be like so annoyed with me. So today we were talking in the van. I said, oh, we haven't done our seeing and unseen or the talk about the concept. So from now in the car ride, what can you see that relates to subtraction and addition? Maybe our car mileage as we drive, it's going up by 1 and 1 and 1. And my son, having a dialect brain, he cracked a joke. He goes, by asking this question, you are adding to my annoyance level. That was pretty funny. I take it well. I took it well, and we all had a great laugh. So it was still talking about addition and subtraction, but not the way I intended it to go.
I love that though. That's fun. All right. Day 1, we also take a look at our math map itself and making sure that we know where we are. And so you'll notice that this is the first week where there's no check marks. So we would need to determine which domain we're in and what lesson we're on. And I'm going to highlight. So we are here on exponentiation. I did not highlight very well. Try and get that. There we go. And you pick, right? So maybe you're in integers. And notice that just doing this, just finding the intersection of those two elements is a skill that we take for granted, right? We think, oh yeah, right? But there's a lot of information, and we're going to talk about locations several times over the course of the year. And this is a way that we can help our students to see, right? There's two sets here, right? So if you wanted to review sets or location, there's a lot of conversations we can have because we are doing exercises that are in the set of exponentiation, right? Or our booklets are all in that same set of the exponentiation booklets. But we're also, my booklet's also in the set of integers. And so this particular case, right, if I turn my pen on, right, is where that intersection is, where both of those conditions are true. And so being able to do that is a skill that's worth taking time with your student to help them to see, where am I on this grid? And how does a grid help me? How are these sets? So you may not be doing that with your smallest or your youngest learners, but even maybe just being able to highlight across a row or down a column, practicing that motor skill is helpful. But with your older students, especially, I would encourage you to think through different conversations you can have just in the math map, because it's tempting to say, well, we're in monomials, we're at exponentiation, I checked my box, move on. But it's helpful to take some time and say, okay, well, what does this really mean? Right? What are the sets? What's in the set of exponentiation? Well, there's all these different booklets, right? Well, what's in the set of monomials? There's still a bunch of booklets. Well, which set has a bigger cardinality? Oh, well, the monomial set has a greater cardinality because there's 30 booklets, where exponentiation only has, well, this year, right, if you've got the printed ones, it only has 5. Next year, it's going to have 10. Right? And so we've got a different cardinality for each of those sets. So lots of conversations we can have here on the math map, and we don't want to just rush past that when we do that.
Kirsty, I
Again,
appreciate you talking about that because, you know, we don't have a traditional layout with our curriculum because we're really focusing on the skill of reading mathematics. So there's a lot of embedded tables throughout the curriculum, because I have discovered over time that students, well, adults have a difficult time reading left to right, right to left, up and down, down and up. And so what you just described is a very important skill in advancing in any form of data collection or large, like think about large language models and understanding how you can sort so much information and find the probability of the words you want to use. So all of this is just really adds to their reading abilities.
yeah, it's like this is kind of the heart of the math map, right? It is the math, and so we want to enjoy all the information that's there and not take it for granted. And then, of course, as I mentioned, when we talk about our approach to math in the math map, we really have to unlearn our old strategies that were jump first to the exercises, see if I know what I'm doing. If I do, I just get them done and check the box. If I don't, then maybe I go back and look at what the writing was and see if I can figure it out. And if it still doesn't make sense, then maybe I'll go look at the table of contents. So our old strategies were working backwards, and we really want to encourage you to work forwards, right? So engage in the conversation, know where you are, then come and look at the lesson pages. We've talked about different strategies, making sure that you recognize how you can use these different domains. Experimenting. So we're only on lesson 7. So I would encourage you that if you're still figuring it out, that that's okay, that it's still okay to experiment with different strategies. And you might find that the 1D lessons, you use one strategy, and when you get to the 2D lessons, maybe it's a different strategy. Maybe your family finds 1 week to be particularly challenging, and so you change things up in that week. So just I continue to encourage you to recognize that you can each week adjust as you need to. Comparing domains is a great way for older siblings to help younger siblings, or for younger siblings to help older siblings, because sometimes looking at those narrower domains is going to give that older student the hint that they need. Then scaffolding, either to help your older student first or your younger student first, depending on that dynamic. You can group the pages by in order, like 1, 2, 3, 4, and then 5, 6, 7, 8, or by content, which would be our 1, 5, 9, 13, 2, 6, 10, 14, and so on. Just taking time to read aloud the pages together is a great strategy. Looking at the tops of the page, or today's strategy is to scale the pages that you're going to complete. And that could be, this week we are playing a lot of games, really doing flashcards, or life went off the rails, so we're doing 4 pages, or we're going to do 8 pages. Or it might mean that I do a few pages from naturals and a few pages from fractions, and then I do a few pages from monomials. So instead of doing all 16 pages in monomials, maybe I've done 4, 4, and 8, or 4, 4, and 4. So changing the number of pages that you're expecting your student to complete is another strategy that you can use. And when we talk about doing portions of the page or not completing every page, I want to encourage you that when you have a break, because there's only 30 weeks, we line up, so there's only 30 weeks of the math map, that over Christmas break, if you have a fall or spring break, certainly over the summer break, you can pull those booklets back out and you still have material that you can go and have your students practice. Any questions about what that looks like to scale the amount or the number of pages that you're doing in the booklet? And you can even, as I talk about scaling the number of pages completed, you could scale how to complete the pages. You might say that on day 1, that they're allowed to use pages 1 through 4 as copy work. And then on pages 6 through 6, 7, 8, 9, no, 5 through 9, sorry, 5 through 8, there we go. On pages 5 through 8, maybe you expect them that they have to make a try at everything before they get to look at the solutions and copy the rest. So maybe that's how you do it, is that you are scaling not necessarily the number, but the way that you complete the pages. So lots of ways to tailor the curriculum. Any questions?
I have a question. My daughter, that's a Challenge 3 student this year, she's doing some in the advanced Saxon math book, but she's also doing the monomials. And I know that probably makes some people cringe, but we're doing actually just Fridays. She's working in the Saxon book, and the rest of the week we're doing the monomials at home. And so she's doing 12 pages in the monomials. And I'm just curious what your thought is. I know there's multiple options, but I guess my question is, we've debated about doing the first 3 sets of 4 pages, or maybe we just do the last 3 sets, or maybe we do the first and then the last 2. And like I said, I know any of those are options, but just wondering if you have any thoughts on that.
I want to answer because it relates to the strategy I was going to share. Something I encourage parents to do, and this does answer your question, Jana, is rip out those solutions and you look at them, those 4 pages, before you start the booklet with your children. Because and this is the number one thing I would look at, how much red ink is on the page. That tells you if it's a week with a lot of calculating or not. And then also, how did those pages change? So when you look at it briefly, you may say, oh, the 2 and 3 set all look really similar. Versus sometimes the first day, the first 4 looks a little more different than the other ones because we're introducing brand new concepts. Well, maybe you can look at those 4 pages and go, yeah, the concepts are basic. I want them to do some of the harder problems that are left on that last day. And so that 4 pages gives you a really quick way to not have to thumb through all of it to make these assessments.
That's good advice. Thank you.
I have kind of a story too, kind of unbeknownst to me. I've been doing like the scaffolding for younger students first, doing my 9-year-old in fractions before going on, while my daughter does her own monomials by herself. And it's interesting to me, like how much I am learning by just doing the fractions with my son. And then whenever my daughter has questions, she'll either be like, oh, I heard you talking to Hezi about that earlier, so then I knew the answer, or I knew how to figure it out, or because I helped my son first and then went to my older student, my daughter, it made so much more sense. So I love that fact.
So Andy, how would you characterize yourself as a mathematician? Are you a dabbler or are you really good at it? Like, let parents know because it seems like you really are figuring out how to use the map.
Yes, I would. I apparently took college algebra in college, but I don't remember it. I can solve for X all day long, but don't tell me to figure out how the inside angle and the outside angle work together. That I don't understand, but I can solve for X anytime. So maybe a dabbler.
Mm-hmm.
All right. Moving on, looking at our lesson pages for day 1. Does anybody have any question about the math that's being explored on day 1? If not, I am going to point out.
Yeah, I would say if you're not going to, could you point out the bottom of the fraction page and how that Trinity works?
Yes. So I want to point your attention to this part right here first, because the exponentiation is a little bit different. When we think about inverse functions, we know that we can count up and we can count down. We can add and we can subtract. We can multiply and we can divide, and they all undo one another because there's 2 numbers, there's 2 parts. But when we look at exponentiation, there's actually 3 parts because we have a base, we have our index or exponent, and we have the power. Now, just as a quick note, we were all trained, and I was watching a video clip of an Oxford mathematician the other day, and he says it too. So we have all been trained that if you saw this expression, we say 2 to the 5th or 2 to the 5th power. And so because of the way that we've been trained to say this, we tend to think that 5 is our power, but it's not. I like calling it the index. Now, in this case, its job is the exponent, but the number itself is that it is an index because it's telling us which power of 2. So if I was to list my powers of 2, I have my 0th power of 2, which is 1, my first power of 2, which is 2, my second power of 2, which is 4, my third power of 2, which is 8, my fourth power of 2, which is 16, and my fifth power of 2 is 32. And so my index is literally that. It's indexing the powers of my base. And so instead of saying 2 to the 5th or 2 to the 5th power, we are all trying to retrain ourselves to say the fifth power of 2, because that's actually going to help our students to go, oh, this is what I'm describing, right? I'm describing where it falls in the powers of 2. And so the fifth power of 2 is 32. So when we look, notice in this expression, our base was 2, our index was 5, and our power is 32. Now, if you said to me, how do I undo that? The problem is that we have to ask ourselves, what do you want to undo? And most commonly, we're taught that you undo it by using roots, right? So if I wanted to undo, right, 30th, the fifth, right, the fifth power of 32, and I wanted to undo that to find the base, this is what we've been taught. You would find the fifth root of 32, and you'd find out that that was 2. But sometimes I might know what my power is, and I might know what my base is. And what I really want to know is, well, which power of 2 is that? In other words, what's my index? And so I have a third function, and that's my logarithm. And the logarithm says that for this base and this power that I know, what's my index? And in this case, it would be 2. And so I love the Trinitarian nature of this. And I sometimes think that the world has done us this great disservice spiritually, because we've taken this 3-part relationship and we said, we're just going to look at 2 parts. And when we do that, right, we're missing out on the beauty of this 3-part relationship. And I don't know if any of you remember your high school Algebra 2 or pre-calculus experience, but I do. I actually also remember teaching this, and we would get to that unit on logarithms, and I'd sit there and I'd go, okay, I have to remember. It's telling me the exponent, right? It never made sense to me because it was divorced from the completeness of the relationship. And so I really appreciate that Lee has rested in just recognizing this relationship. And so if you look below, notice all that we're doing is rewriting this. So when I see 4 squared equals 16.
Hey, Kirsty, before you go on, just so people aren't confused, you wrote 2 when you meant to write 5.
Oh, yes, I did. Thank you.
Okay, keep.
When I see 4 squared equals 16, the first question I want to ask is, what part is each of those? So I would say, what's my base? My base is 4. What's my index? My index is 2. What's my power? My power is 16. And once I know that, I can rearrange those pieces and put them where they are. And I can then see that the second root, or the square root of 16, is 4. And the logarithm, right, base 4 of 16 is 2. And so I'm not actually calculating, I'm reading these by identifying what part are they, and then I'm reading. And our students are going to be invited to really make sense of this 3-part relationship. So, Nicole, you have a question.
Yes, I guess my quick question is, can you help me know where to use the word exponent?
Sure. So there's 3, I don't necessarily want to say nouns, because we can talk about, but if you think about 3 nouns or 3 people, the 3 people in this relationship are the base, the index, and the power. So that's almost like their proper name, right? And so just like, there's Lee, there's Kirsty, there's Nicole, right? We each have names. Well, we also have jobs that are unique to us. So each of those those pieces have a job. So in 4 squared equals 16, 4 is my base, and it's always my base, but the job that my index is doing here is the job of the exponent, right? And then the job with the root, right, is to calculate the root. So we've got some neologisms. I like that word. Right, the made up words rooterate and logorate. So we can exponentiate, rooterate, and logorate. And that's where I would use exponent, is to describe the job of the index. So in the power expression, the index is an exponent telling me how many times to use my base as a factor. Does that help?
I think so. You said the index is an exponent that tells me how many times to use my base.
Yes.
I have to
So on the
marinate on
first
that.
one,
Thank you.
yeah. So in the first one, she has your exponentiating, and then your rooterating, and then your logerating. And so that's another way to get the three next to each other and keep them combined until it becomes much more familiar to say the right word at the right time. You know, it's no difference than when you learn anything else. You know, you were in the kitchen and you look at your husband and say, hand me that thingy over there. Right? We kind of have to do that for a little bit before we say, hand me the spatula with the 3 holes that's metal, not plastic. And so this is a place to really work on language with our children.
Kirsty, did you see the questions in the chat?
I did not.
So one of them is the log, she said, I've never heard the third part before. Is there a particular branch of math that uses the log base power equals index?
So the power of log, well, anytime I want to know what the index is, right, that's where I'm going to use my logarithm. It's very useful when I have numbers that are very spread apart. That's where we oftentimes see logarithms used, because with my logarithms, I can take, for example, if my numbers were 10, 100, 1000, if I'm trying to graph all of that, you know, especially if my next one was 10,000 and then a million, right? My values get stretched out like this in order to keep that high one, and these are all really close together. So that would be my sort of my linear scale. But if I look at a logarithmic scale, I'm going to look at those indices instead. And now I can look at 1, 2, 3, 4, 5, and they can fit into right, a smaller space and give me a little bit different information. So you're going to see as you
I say, Kirsty, look right above where you were working. This is exactly what you just described.
and I was just going to say, if you work through these lessons, you're going to see that Lee includes some examples like the Richter scale and decibels, right? The Richter scale is a logarithmic scale. And so what that means is that if I go from a 5 magnitude to a 6 magnitude, it's actually multiplying. It's not adding a little bit more. So going from 5 to 6 to 7, it's not just a one step, right, from 5 to 6 or 6 to 7. It's multiplying. So if it's 10 from 5 to 6, it's going to be 100 from 6 to 7. So that helps us to see, right, that when we use these scales, all right, a 7 is so much more horrific of an earthquake than a 6, versus how much worse a 6 is than a 5. Right. Our pH scales work the same way. Our logarithmics, our Richter scales, our decibel scales. So we see them commonly in scales, but also if you were a data scientist and you were looking at data and your data is really spread out and you have maybe a lot of things that are here, but you've got these outliers that are way up here, by transforming that and looking at it logarithmically, we can see different patterns. without losing, right, everything being scrunched together here. It gives us an opportunity to spread things out. So that's the sort of the application of the logarithm. I just think it's, to me, it gave me a different way of looking at the Trinity. So spiritually, it taught me something to understand the threeness of this relationship that can't be pulled apart, right? It's one relationship. It's between these three parts. And so I'm not saying that this is how to understand the Trinity. I am not giving us a lesson on the Trinity. But for me personally, when I realized that to understand this, I needed to see all three parts, it made me appreciate that when God talks about himself being three parts, a Father, a Son, and a Holy Spirit, I can't just look at the parts that I like, right? If I just look at Jesus and he died for me and he's all about loving one another and the Holy Spirit's my comforter, right? If I just focus on those two parts of the Trinity and I ignore God the Father, who, established law and is holy and right, like I need to experience all three parts of God and together. And to me, that's one of the things that I learned here when we recognize that this is a three-part relationship, right? And if I just look at two parts, I'm missing out on that third one. And are there other questions, Babs? That may be more than whoever asked that question wanted, but
Jana said, is an exponent like the species of the index?
She's talking about genus species.
Yeah, genus, like the index is the genus, and then an exponent would be kind of like a type of index, a specific name. I mean, you use the word job, but I just,
yeah, that's an interesting, because then it's just called the index of the root, right? But it's a root. Is that the species? Like it's got these three species? I don't know. That's interesting because it's the result of the logarithm. So it doesn't necessarily go with the operation, right? It's an
right.
exponent telling me this is the operation. It is the root, so it's telling me the operation, but now it's the result of the operation, not the operation itself. So I think I'd be hesitant to maybe go that far.
Yeah, I hear what you're saying. I like that these words logarate and rooterate, because I mean, exponentiation, that's a significant, thing. But I don't know, it feels like the other two are lacking in a nice Greek Latin root name.
It's true.
Well, see, that's why we have the word neologism, because it gives us permission to make the words that we need.
I might work on a new one though. Rooterate is not quite, it makes me think more of plumbing than than advanced mathematics.
Is it a little bit too much like roto-rooter?
Yeah, I think so.
Well, it does get to the heart of the problem.
So Jill was asking, in the order of operations, does the index include the roots?
Yes, it does. Yeah. And so that's one of the reasons why we used index to say, hey, simplify your indices related problems first, not just your exponents. That was intentional in choosing I for index instead of E for exponents. Other countries use order versus index. So if you were looking at, sometimes you'll find something from another country and you might see like BODMAS is a common acronym, and that O stands for order, which is exactly what our index is, right? So 16 is the fourth order of 2, right? When we put it in order. So index and order have a similar meaning in that case. So that's another thing you might see if you are looking at something that's international. All right. So we spent a lot of time there. Do you have another question, Babs?
Nope, we're good.
All right, so we're going to move a little bit more quickly because I know we're sort of getting low on time, but I think that was a helpful conversation. So on day 2, we are looking at our I² invention page. And remember that we are not, our goal is not to look for understanding the math on these pages, but for practicing our common topics of invention that we can use for looking at any type of reference material or for looking at our exercises. So we're practicing these common topics in order to be able to use them elsewhere in the lesson. So going back to our start, we're looking at definition. And there's 2 things we can think about with definition. We can look up unfamiliar words. We can find those definitions on the charts, in the glossary, or in the companion. Or we can use our dialectic skill of definition by talking about what class does a word belong to. In other words, how is it like other terms or concepts? And then we can say, well, how is it different? What makes it stand out from the class? So the first is more of a grammarian approach to definition, and the second is more of a dialectic approach to definition. We can practice both or one, depending on the needs of our students. But that's what we're doing on our I² invention page, is practicing those topics. And you'll notice that we're going to continue practicing these 3-part relationships on each of these pages. So I just want to point that out, that if you look here, we're looking at the 3-ness, right? Powers, roots, and logs. But now we're looking at it with regard to the laws. But we're still going to continue to see that pattern as we move along. So it's really helpful to your students to help them see the comparison. And I just want to remind you, right, to really look and say, okay, copy, copy, simplify. So make sure that you're looking at those instructions, because some of these may feel really overwhelming when a student looks at them. And then when you remind them that all they need to do is copy, right, it brings us down a notch. On day 3, we're looking at I³ Memoria and Arrangement page. And here we want to practice our core habits of Memoria. And so we're cycling back to naming. And so just as we were talking about with the math map, right, just looking at a table and being able to say, what are the row and column headings? For your younger students, it might be the rows, right? Let's name our rows. Which are the rows, right? The rows are the horizontal. So just working through and saying commutative, reading these words together, associative, and then talking about which are my columns. My columns are roots, exponents, logarithms. So again, just practicing with your students how to read a table. If there's a lot of sections on the page, you could name the sections. In this case, there's only one, and it's the laws of exponents. Right? And so just being able to look at a page and name it, notice that's a skill that is worth practicing to help us when we look at other reference materials or when we're looking at our exercises, is just being able to name things before we jump in and try to understand the math. On day 3, we're encouraging you to consider some quick flip arithmetic games in addition to the flashcards, that those are going to give you a way to practice your computations and calculations in a fun way. And Yating, yes.
Sorry, I have a question about do you have any practical strategies for a student who are very eager to learn? Like, they almost have too much of a eagerness to, I hate to say that, but it's like he wants to understand. And yeah, mama is telling him that, well, copy is just fine. And but he wants to understand. So when and where and how would you do that, and not just racking the rhythm of going through the pages? Or do you just stop and just explore and follow the rabbit trail? Because that, I think in my mind, that's breaking the rhythm of there's a rhythm to it, like every week, every day when you do it. So yeah, if you can share some insight, that would be awesome.
So I think one, if your student is really intrigued by something and wants to follow a rabbit trail, there's nothing wrong with that. But I want to address understanding that if our student says why, and we sit there and we explain the why, we are giving them a grammar level understanding and not a true dialectic understanding. And there's nothing wrong with that. There's nothing wrong with that as long as we recognize that. And I think for a student who's eager to learn, helping them to see the difference and encouraging them that developing their own understanding, having that light bulb moment is worth persisting. I think that that's going to help them to not always come back to you and say, well, just explain it, right? Because that's the easy way out, right? Getting a dialectic explanation for something is the easy way out because we hear it and it might make sense, but we haven't made it our own. So I would encourage that student to say, okay, well, I want you to take a look at this and I want you to see if you can figure out what the pattern is. Can you connect words with the process? Can you tell me what the process is? Can you create your own problem? There's ways to push that student that wants to understand and really help them, instead of giving them a didactic explanation, to pull those core habits in, to pull those common topics in and say, okay, well, I want you to go and answer these questions. I want you to go and practice these core habits and then come back and tell me what you think this is about. And then you may need to refine a little bit. So we talked about that with a companion, that the companion has in it the didactic explanation for a parent, not for the parent to turn around and transmit that didactic explanation to the child, but so that as a parent, you can get a sense for what questions would be helpful. How do I lead them to ask good questions or name things? So does that help a little bit?
Yes, because I do find myself revert back to didactic teaching a lot because I have a very eager to understand student, and at this level I can still handle it, so I revert back to didactic. And but then I yeah, it's not the true true well I think it's not the true meaning for it. Yeah, yeah, it's easy way out. You're right. So
So you ting, something to remind you guys, just because I'm a lot older and all, I got grandbabies that are old now. A major natural aspect of learning is frustration. And it is not something to be relieved. It is something to be lived through. And that's where a lot of times parents and teachers make a mistake. And all you need to do is remember when your toddler, gosh, he knew what he wanted, but he didn't have the language skills yet to say it. And you're stuck guessing, and he's having a temper tantrum because he knows so well what he wants and no one can understand him. That is very frequently the nature of a very curious person. At my age, I experience it daily. And I know if I don't have that frustration sometime during the day, if I can't look back and go, well, that was really hard, that I didn't learn that day.
totally,
I like
so much.
And something that when I was speaking in Palm Beach a month or so ago, I had a light bulb moment for myself that I realized, like you, it was really easy for me to, slip into didactic teaching with my children. And I was excited and I wanted to let them know, right? This is really cool. And I jumped in and I think I prevented them discovering the joy for themselves. And I sometimes think that because I knew it so well and I was going to tell them what they needed to know, I didn't let them discover, and they didn't fall in love with math the way that I did. Right? So my very tendency to jump in and explain all the cool things meant that they didn't have the opportunity to discover and wrestle and fall in love with math for themselves. And so I think I love that Lee said that. That's a natural part of learning, that frustration. And if we don't let our children have the success of figuring it out, then we're stealing from them the opportunity for joy. Nicole, you have your hand up.
Yeah, can you stop that, please? I was gonna say, um, at the math at home training that I did last week, and that I said this a few times, that one of the things that I tell them is that this is not just a math curriculum, it's a curriculum that will help you teach your child how to be frustrated well. And I say that all the time, and they always laugh, but I go, I remember being so frustrated when I was looking at the naturals and being like, how is this a first grade curriculum and I can't even read the problems? Like, I was so frustrated. And my son was like, Mom, it says trace. And I was like, okay, yeah, you trace, but I should be able to read it. And I remember having these multiple moments of like, if I keep being super frustrated with this curriculum, I'm gonna pass that on to my kids. And it was like it was like God's way of getting my attention and being like, you are not frustrated well. When you get frustrated, you need to learn, what do you do with that frustration? And so then last year when my daughter was in challenge A, and she would say, Mom, how am I supposed to know how to do this? And my inside response was, I don't know. I don't know. I don't know how to do it either. But then I learned how to say, well, what do we do when we don't know something? Right. And I learned how to say, I'm not sure either. Let's look at our resources and try to figure it out. And so for me, it actually was training in how to be frustrated well. And
Yeah.
hopefully for them too.
You know, we know how to do this. We do it all the time when we're doing a Bible study. Not a one of us thinks when we read our Bible, we know what the author meant. We know we are just neophytes trying to hear his heart and his message and obey it. And so people have wanted us to have the math curriculum like they're used to, where you just turn the page and the next thing's got everything you want and it's easy for you. Well, that makes really weak Bible scholars and it makes really weak math scholars. So when I study my Bible, I go use my concordance, my interlinear Bible, I go use my Greek Bible, I pray with the Holy Spirit, I'll go get maps, I'll go get commentaries. And doing that over and over again for a lifetime is what makes it so the Bible is understandable to me. And in a sense where, yeah, I still don't know what in the world God wants, but boy, do I trust him. And boy, do I want to do what it says, even when I don't understand it. And that's how you learn science and Latin and everything, is you go after it many, many different ways. And so you learn how to overcome frustration rather than succumbing to it and giving up. And most children under 15 can't do that. And that's why they have parents who can break it down into bites or say, today's too hard right now, go play basketball and come back and we'll try in 20 minutes. Because we know they're children, not adults.
Yeah, I tell him to go walk the dog. My poor dog's being walked very well. So is there a time or place that we could, so we talk about how, and so when do you think we can follow those rabbit trail? Is it something like maybe we can pull out the companion or, even go figure out like the videos or something like that? There's a place for didactic teaching, but probably just not during the hour that we're doing the logic. So when do you think that maybe, like I'm thinking about like very practical ways of time, pockets of the days where you slip it in. Like how do you slide it in?
Oh, I think if there's something that he's really wrestling with, you say, look, just work on this page today, right? You don't have to do it all, because guess what? We're going to see it again next year. So if you really want to understand, right, how to rewrite exponentiation to roots to logarithms, well, keep flipping cards until you go, oh, I get it, right? Keep doing this until that light bulb goes off and then come and tell me. And if that's what he does, then that's okay. That kind of a rabbit trail, I think, is okay. Versus, I would always encourage you for you to go and use the resources and for you to go and say, okay, this is the didactic. I've got that. And then come back and say, hey, try this question, or what if? And so you start asking him questions instead of just teaching. I was really blessed, and I didn't know this at the time, but I was really blessed in ninth grade biology because I was absolutely fascinated with bacteria. I don't really know why, but I was. And I had a biology teacher who moved on with everybody else and would let me sit in the back of the room making petri dishes and growing bacteria and looking at them under the microscope for weeks. And right, somehow I learned the other stuff, I guess, but I just remember the joy that I had in examining all of these different bacteria for weeks on end, and the blessing and the glory of having a teacher that allowed me to do that. And so she didn't tell me, she was teaching other stuff, right? So that's where I would say that's the kind of rabbit trail to encourage your son, is not time where you sit down and you teach him, but time where maybe you help guide him to go and find more examples, right? You want to look for this? We'll find the pattern. Let's go find some examples. I mean, that's one of the really great uses of AI, right? Is, hey, we really want 30 exercises where my son has to do XYZ. Well, go work on these, not to become a great calculator, but to look for the pattern that you're noticing.
That's amazing. That's amazing use of AI. Thank you.
Yeah. Well, because of time, gals, Kirsty, why don't we end the formal part of the conversation and go on to yours? Want to give time for questions at the end, and then we can go there. And I mean, look, the Lord apparently just needed us while we were talking about the most frustrating thing in arithmetic, logarithms, to vent and just encourage on why our children get frustrated and why we do too.
So yeah, and actually what I had there on our careful calculations page was all about looking for patterns. So that's what we just talked about. So God knew and covered us. We did have somebody send in a question this week, which was, how do you make the jump from skip counting to flashcards? And I asked Lee this question yesterday, and unfortunately, the answer is not simple. It is time and practice. Some things that I wanted to let you know. Skip counting is a verbal skill where multiplication is a computation math skill. It's going to light up different parts of your brain. So we oftentimes talk about skip counting as a great pre-skill for multiplication, but it's actually going to be using different parts of your brain. And so part of the issue is making that connection between your brain parts. One way you can do this, or here's many strategies. None of these are going to necessarily work in isolation or for all children. But one, you can extend skip counting by practicing counting on. So instead of starting from 0 and going 3, 6, 9, you can start at 1, right? 1 plus 3 is 4, plus 3 is 7. So I'm going to count on instead of just doing my skip counting. So that's going to extend that skip counting in a little bit of a different way. You could start by not necessarily worrying about what the product is, but emphasizing what the factors are. So when you're looking at a flashcard, I don't have multiplication or addition flashcards in front of me, but the first few times you go through the flashcards, just read that 5 times 4 equals 4 times 5. So now we're just practicing the commutative property, which is easy to skip over, right? And we're reading, and so we're getting those facts in our brain, even if we're not saying what the product is. You could examine other linguistic patterns. So in England, they don't necessarily do their multiplication tables the same way we do. They learn 1 2 is 2, 2 2s are 4, 3 2s are 6. And so that different linguistic pattern may help to make a connection between the multiplication and the skip counting in a way that 1 times 2 is 2, or 1 times 2 equals 2 doesn't. Again, it may work for some and not for others, but you can consider those different linguistic patterns. It can really help your student if they connect the multiplication facts to images. So for example, there's 1 2. There's 2 2s. There's 3 2s. And so now my brain is connecting that pattern to the facts. So you could even have your students drawing these arrays as they're practicing the facts. Or they might think of groups, right? I have a group of 2. I have 2 groups of 2, which is 4 items altogether. Or you can pull out the back of lesson 5, I'm guessing, but Babs can correct me if I'm wrong, and use the multiplication chart, right? So now that's going to actually, because it has 1 through 15 and 1 through 15, so that's going to help me to visualize because it's got the array built in, right? That's going to help me to see what that pattern is for multiplication. So helping to connect an image to the fact is another bridge to memorizing those facts. And then you can always practice through games. So for example, playing multiplication war, where you have 2 people and we're going to turn over 2 cards and you have to multiply the cards, right? So that takes the same facts that we're practicing on the flashcards, but now it's putting it into a different scenario in a different order and is going to trigger our brains differently. So lots of different ways that we can help our students to work from skip counting to flashcards. Know that when we sing the skip counting songs, it helps us to remember, but we're remembering a song, we're not remembering a mathematical pattern. So that goes back to that idea of it being a verbal skill. So you may want to de-emphasize the songs if you're trying to move to learning the math facts. So those are all some ideas. Does anybody else have anything that they're like, oh no, this is the magic, it worked for us? And nobody is stepping up. I think we've all struggled.
I think I'm struck by the fact that you said the songs are not memorizing a pattern, because I thought they were. And really what the transition that we've done with the first 3 of my kids, I still got 1 more to go. He's a little different, but is we put the whole math fact up, like 2 times 1 is 2, 2 times 2 is 4. Then we sang the 2s down the answers, and then we went back and then we said the entire equation sentence so they could see the pattern that they had memorized and how it fit into the actual times table, like the 2s. And that seemed to click for them.
That's a great
There's
strategy.
nothing, yeah, and there's nothing wrong with the music. Just recognize that sometimes it's kind of like if I asked you what letters before J in the alphabet, you kind of have to say the song in the right order to answer me. And so that's just a difference between the skip counting where you're building vocabulary, you're building patterns, you're showing them that math is a natural state for them to be thinking about. But that's not the same as being able to tear it apart and calculate with it. But when they do the calculations and they're learning it, they can go, wait a minute, I know those words and I know the pattern. Right? So there is a back and forth, but they are 2 different mental tasks. Kirsty is right.
Also, I find that when
Yeah, once we went, oh, sorry.
when we went to like skip counting, and then last year 2 of my kids became memory masters, and when they have to randomize and show the cards, like the adults have to prove them, it's almost like they got a photographic memory of it. So they actually, what's 2 times 4? Oh, 8. 4 times, because the flashcard is laid out so well and you show it to them so fast and so quickly, they start developing that photographic memory. Now the problem is they see it in a flashcard form. When they see it on the math map book, the worksheet, then that's when they have to make another transference. So I'm just thinking through how that transference might occur. But yeah, it's almost like they actually had a photographic memory, or they just memorize it verbally to computation.
Mhm.
Yeah, I think I just really appreciate all that because you're just showing that you're thinking about the pedagogy and how children really operate and actually how the brain operates and how learners operate. You can break things down into different skill sets. And that's again why grammar, dialectic, and rhetoric are so important to know which is it I'm practicing. Am I building my eidetic and audio memory? Am I building my sensory memory and the grammar? Or am I thinking, and getting frustrated, because I'm being dialectic now? And we all do it, every one of us.
Well, that's great. I think this is a great conversation, and just like Lee said, there's frustration. We all learn differently, and just having to persevere, right? Sometimes some things click faster than other things, and so learning, right? In our homeschool, I'm not calling out anybody else's, but in our homeschool, right, whether it was me or my children, our struggles were usually not academic. They were usually struggles of character, right? I don't want to do this because it's not exciting to me, or it's hard work, or, right? That's a character issue versus an understanding issue. And as parents, we can help with the understanding issues by asking good questions and emphasizing our skills of learning. But the character issues are the ones that are the hardest ones, and sometimes don't always have the easiest answers, um, other than a lot of prayer and a lot of modeling from us as parents and a lot of patience as we remember, as Lee reminds us, that these are children, and so they're not going to be ready to handle everything with the same maturity that we are. So, well, thanks everybody for being here. I am happy to answer any other questions. If somebody came with a question today, I'm certainly happy to answer that. But at the same time, I recognize that we have gone over. And so if anybody has questions, I will hang out for a few minutes. Otherwise, we will look forward to seeing you all next week.
Okay, I do have one question. I think it's quick. You said the explanations that we get on the companion are not necessarily to help parents know how to go back and teach the kid. It's more to help the parents develop proper questions for how to teach the kids. So, okay, I think I know the answer now that I'm saying it out loud, but like, how do we know when to use the word you used last week? How do we know when to let them in on the algorithm?
Well, there's no easy answer, and it's going to depend on the student, and it's going to depend on the concept, and it's going to depend on you. If we can, so here's an example, right? To me, if every child leaves the math map and they say, all I need to know to multiply is that I need to memorize through 9 times 9, right? I need to memorize my facts through 9 times 9. More are helpful, but memorize my facts through 9 times 9. And every other multiplication exercise is an exercise in using the distributive property, right? If students knew that, I would say these are some really smart students and there's nothing that they can't multiply, right? Because they know how it works. That is multiplication. That is all you need, right? Now, that might not be, right, immediate. So that's where we might need to help them to see it. So that's why Lee has us multiplying, right, like, oops, let me go back and turn the pen on, right? So we have like 4 times 12, right? Well, I could see that that is 4 times 10 plus 2, and I'm going to distribute, and I get 40 plus 8, which is 48, right? Or I could have 12 times 4. And I'm going to distribute my 4 over my 2, which is 8. And then I'm going to distribute it over my 10, right? This is why helping our students to see the place value is 40. And so I get my 48. I think here it's a little bit hidden how we're distributing because we haven't pulled it apart like I did up above. But, and then even with, right, somebody said, you're teaching things like Common Core. Well, right, Common Core might have your students do this. I have 0 tens, right, times this. 4 times 110 is 4. 4 times 2 is 8. Then I go along my diagonals and I get my 4 tens and then my 8 ones. And so my answer is 48. And then we have the Japanese, like 1, 2, like however they do it. They do some weird thing with lines crossing. I can't remember exactly, right? There's all these different methods that are out there for how to multiply. They're all just different ways of keeping track of distribution. So the problem with only teaching our students this and saying, okay, 12 times 4, or let's make it 13 times 4, right? Because then we have to carry. So 3 times 4 is 12, carry my 1. 4 times 1 is 1 plus 1 is 5. Now, they can use that algorithm, but they don't really know what they're doing. They don't really know why they're carrying. They don't really know that they're using the distributive, right? Because they're just seeing that algorithm. Now, what we want to help to do is help guide our students towards going, oh, all of these different things are the same. Now, I'm going to acknowledge, right, 99% of people that are teaching mathematics, including teachers in the public schools and in the private schools, and I'd say probably 99% don't recognize that this is all just different ways of using the distributive law, right? Because we just keep teaching different algorithms. So the complaint with Common Core wasn't the idea behind Common Core. It was just that they said, instead of saying, hey, we're going to lead people to discover that this is all the distributive property, they said, we're going to trade this algorithm for this algorithm, right? And so we just traded algorithms without ever saying, do you see why they're the same thing? And so that's why we want to be hesitant about jumping in with the algorithm because we don't necessarily understand what's behind it. And so if we can have our kids this, right, and say, okay, look at the horizontal and now look at the vertical. What's the same? What's different? What do you think is going on? And if they're getting really frustrated, then you maybe say, well, what do you think you did here? So you might be teaching the algorithm, but you want to do it by asking them questions. What do you think you did? Well, what are you doing when you do this? Why do you do this? Why does that 1 go there? What does that really mean? So if you spend half an hour on 13 times 4, but you've talked about the distributive property, you've talked about place value, you've talked about trading, right? That's a really rich conversation that's going to advance your students like a step towards understanding that just teaching the algorithm doesn't. Does that help?
That was tremendous. And I was today years old when I found out that stacking was the distributive property. So I learned the algorithm without learning what was behind it as well. And I can see I'm enlightened. Yes, thank you. Even just the example you used helps me understand why I should hold off on that. Because yeah, that was informative.
I feel like we're all in that boat. Like we all memorized algorithms and formulas and we don't know what we're doing. And so when it's presented a different way, we're like, well, I don't know how to do that because that's not how I was taught, right? So, yeah.
Wow. Yes.
Again, redeeming math for ourselves, right? Thank you so much.
Yes. Well, I'm glad I asked the question. I wasn't going to ask, but I'm glad I asked because that was super helpful.
Well, I'm glad you asked too.
All right. I will bow out now.
Well, you guys have a great week. And yeah, next week we're going to wrap up 1D. And so I think, honestly, I think 1D is the hardest of our dimensions. And so next week we will all celebrate that we did the hard things and we persevered, and then we can have fun playing in 2D. So.
Thank you so much. Have a great one.
Thank you.